Continuing from where we left off in the last video, we saw that sometimes our denominator comes out to be 0. We have some problem when we're trying to use direct substitution. And if that's the case, well, we can try some other things out. We can try to figure some things out. Now, on the last problem we saw in the last video, we were able to factor and reduce things and essentially remove the problem. And that was an example of that removable discontinuity that we had seen in the past. It says, it's customary to describe a resulting fraction of 0 out of 0 as having an indeterminate form because you cannot determine the limit of the function with 0 in the denominator. A limit of this type may exist and have a real number value, or it may not exist. It even could diverge to positive infinity or negative infinity. And so this is the one we looked at in the last case. Remember we talked about, we actually worked through this and got a value of 2. And notice right there, although it did not work right there at 2, when we plugged in that value, the limit still existed. It was still approaching 2. When we put in a 1 originally, the direct substitution didn't work. We had division by 0, but it was in indeterminate form. We could not determine the limit in the form it was in. So we worked through this, we factored the top, we canceled things out, and we were left with x plus 1. And notice that's what this line looks like. This looks like x plus 1, but just with a hole where we had our problem. Okay. So let's look at some more examples of how we can try to use this. If we plug in a -4, clearly it doesn't work. But we can try to factor. Right now this is an indeterminate form, so let's factor this, be x plus 4, x plus 4 times x minus 5. Now we can plug in our value for -4, and we get a -9. So the limit as x approaches -4 would be a -9 in this case. Over here, if we plug in a 3, this would give us a 27 minus 27 minus 21 plus 21. Well, 27 minus 27 is 0. Minus 21 plus 21 is going to be, it's just all 0. So that would give us a denominator of 0, but we can try to factor out this denominator, hopefully cancel something out. That's the hope. Okay. So it looks here that I can factor by grouping. So this whole problem is really x minus 3 over x squared minus 7 times x minus 3. Our x minus 3's are gone, and we're left with 1 over x squared minus 7. Now, if we plug in the 3, we can determine the limit. 1 over x squared minus 7 would be 1 over 9 minus 7, which is a half.